Okay, so this is homework set 1, problem number 4. So we're given that the probability of A is equal to the probability of B is equal to the probability of AB. Therefore, is A equal to B with probability 1? So A is equal to B with probability 1 if this inequality holds. So if the probability of A bar times B plus B bar times A is equal to 0. So in order to apply De Morgan's law to this probability, we need to tinker with it a little bit. So we apply a little bit of logic. So therefore, if the probability of this quantity is equal to 0, then the probability of the inverse of this quantity has to equal 1. So that is what we did. And now, with this new inequality, we can apply De Morgan's law to the inside. So applying De Morgan's law to the inside, we get A bar times B quantity bar times B bar times A quantity bar. The probability of that is equal to 1. So in order to save myself a little trouble, I decided to just simply evaluate the inside of this before putting it back into the probability. So on line 3, we can then apply De Morgan's law to these two parts. So applying De Morgan's law, so this second part of De Morgan's law, we come up with A double bar plus B bar quantity times B double bar plus A bar. So A double bar is simply just A, and B double bar is simply just B. So we come to line 5 resulting with A plus B bar quantity times B plus A bar. And so after foiling, we get A times B plus B bar times B plus A times A bar plus A bar times B bar. So B bar times B results in the null set. The probability of that is equal to 0. Similarly, A times A bar is equal to the null set, and that is equal to the probability of that is also equal to 0. So we just end up with AB times A bar times B bar, and then these two can be put back into the original probability. So we result with the probability of AB plus A bar times B bar is equal to 1. So we can expand that probability further into the probability of AB plus the probability of A bar, B bar minus their intersection, which is the probability of A times B bar times A bar. So we notice that B times B bar results in the null set, and A times A bar is equal to null set. So this whole entire probability goes to 0, which makes things a lot easier for us. So we just end up with the probability of AB plus the probability of A bar times B bar is equal to 1. We can also expand the second part further, since by using De Morgan's law. So the probability of A bar times B bar is also equal to the probability of A plus B quantity bar. So then we end up with the probability of A times B plus the probability of A plus B quantity bar is equal to 1. So the probability of A plus B bar, or B quantity bar, is also equal to 1 minus the probability of A plus B. So now we have the probability of A times B plus 1 minus the probability of A plus B is equal to 1. So the ones can cancel out, and we can expand again the probability of A plus B out to the probability of A plus the probability of B minus the probability of AB. But since there's a minus in front, we can take account of that. So it results in the probability of minus the probability of A minus the probability of B minus the minus resulting in a plus the probability of AB. So finally we have the probability of AB minus the probability of A minus the probability of B plus the probability of AB is equal to 0. So now we can use our initial conditions and plug it into this equation. And therefore, if this equation holds at the end once the initial conditions are plugged in, then A equals B with probability 1. So since our initial conditions state that probability of A is equal to the probability of B is equal to the probability of AB, then the probability of AB, since it equals A, this AB minus A results in 0, and negative the probability of B plus the probability of AB also equals 0. So we end up with 0 equals 0, this equality holds, and therefore A equals B with probability 1.